Hello PU1 champions. So your FA-1 exams are coming. So some of you have requested us, sir, please do something for PU1. So today I am going to discuss the most important questions from all chapters of your FA-1. So if you are watching us for the first time, so definitely you have to subscribe to our channel. Definitely that will give us motivation to make more videos for PU1. And if you obviously feel that this is helpful for you, don't forget to give it a like, so that again, as I mentioned, we will bring more PU1 content if you like our videos and obviously subscribe to our channel, right? So today for FA1, obviously physics can be felt a little difficult because obviously in physics we do a lot of mathematics for you in the first half of your journey, and that point of time you may not have enough knowledge about mathematics, obviously differentiation, integration, etc. Sir, what are those? I do not understand. Don't worry. Actually, in the exam pattern are straightforward, and you don't need to remember all those differentiation and integration as for your FA1. So I am going to help you with all the important questions for each chapters. And what are all the chapters that are going to cover in this session? Units and measurement completely, motion in a straight line, motion in a plane, laws of motion. So these first chapters we will completely cover in our session. Obviously these are the chapters that you have full chapters. Work energy power is there in your syllabus up to collision only, and we have picked up some of the important questions from work energy power as well, but major focus of your preparation should be on these four chapters. Work energy power will come at the last priority. If you get some time, prepare this chapter. Otherwise the first four chapters are super duper important, and if you prepare it, you should be able to answer all the 35 marks required for your preparation. Now how these 35 marks will be divided, that is also some students do not know, because obviously you are in PU1 and this is your first exam that you are going to write, right? So what will be the question pattern? So there will be 7 MCQs, there will be 3 fill in the blanks, no option here. There will be 2 marker question, okay, 2 into 2. There will be 2 3 marker question, 2 into 3, okay, and there will be 2 5 marker question, 2 into 5, and 1 numerical, okay. So 1 into 5. These are derivation and these are numericals. Sir, will you cover numericals in this session? Yes, I will cover numericals also in this session. So don't worry. If you watch this, definitely you should be able to answer all 35. And if you watch this again and at least 2-3 times, then there is a high chance. And if you practice those questions again and again, then definitely you will be able to score 35 out of 35, right? All the best. Let's start. So first chapter we are going to discuss units and measurements as usual. First chapter and first type of questions are obviously MCQs, and many of you are actually struggle with MCQs because in the MCQs that you have attended in your class 10th were slightly easier, but in PU1 onwards the MCQ questions can be little tricky if you are not prepared well enough, if you have not gone through your NCERT textbook. So practice MCQs is very important. So let's start. Which of the following statement is incorrect regarding significant figures? So you have to find the incorrect statement. Okay, I have highlighted it in the exam paper. This kind of highlight will not be there. So you have to read the statement carefully before answering any of the question. Incorrect means 3 of them are correct. Only 1 is incorrect. That one you have to identify. All non-zero digits are significant. This is a correct statement. So this is not our incorrect statement. All the zeros between 2 non-zero digits are significant. So let's see whether they are significant or not. So for example, 3003. So these 2 zeros are significant because it is sandwiched between 2 non-zero numbers. So definitely second statement is also correct. The trailing zeros in a number with the decimal point are significant. So if you write say 3000 point or a decimal, if you as soon as you add the decimal, all the zeros become significant. So this is also correct statement. the power of 10 is counted while counting the number of significant figure. So if you write say 3 into 10 to the power of 3, then this number is not counted as significant figure, only this is the significant figure. So this has only one significant figure. If you are writing the number like this, then all the zeros are significant. But if you are writing it like this format, scientific format, then only the number which is written before the 10 to the power is significant. Anything that is there are not significant. So 10 to the power value is not significant. So this is an incorrect statement. So option D is the correct answer for this question, right? So if you read the questions carefully, you will be able to find out the correct statement. Now all of them are 3 of them are correct, only 1 incorrect. So that can be little tricky if you are not paying attention. Which of the following physical quantity has same units in CGS, FPS, MKS and SI system of unit? So CGS is old system, centimeter, grams, seconds. MKS, FPS is foot, pound, second. MKS is meter, kilogram, second, and modified MKS is our SI system, right? So in every one, if you see that second, 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 so each of the unit, including SI system also, the unit of time is second. So dimension of time is same for all units, no matter what. So it is time. Okay, units are same in every standard that we use, either MKS or FPS or CGS or SI. The unit of time is always second. So for that's why time has the same unit in all different measuring systems, right? Now let's move on with the next question. Which of the physical quantity is not a fundamental quantity? Very important. Which of them is not a fundamental quantity? So if you forget, there are 7 fundamental quantities, right? Mass, then we have length, then we have time. Okay, these 3 are very common. Apart from that, we have temperature, we have current, right? We have the intensity of light, right? So these are the, and mole number. Okay, the number of particles in a given substance. Okay, these are the 7 fundamental quantities. Now if you see that here, length is a fundamental quantity, temperature is a fundamental quantity, electric current is also fundamental quantity, but energy is not a fundamental quantity, it is a derived quantity. Okay, energy comes from the fact, if you have studied work energy power, half mv square or mgh, whatever form you use, so that is not a fundamental quantity. So energy is a derived quantity. So option D is the correct answer for this question. Now next is the SI unit of electric current is. So SI unit of electric current is ampere with a small letter. Remember, ampere with a small letter. If you write capital A, ampere, that becomes the name of a person. Okay, so who actually did a lot of work in the field of electricity. That's why to honor him, the unit of current is named after him, ampere. But either you are writing the symbol capital A or you are writing ampere in a whole with the small a, right? So here ampere is the unit of current. Next, the SI unit of solid angle. So there are 2 types of angle, plane angle and solid angle. Solid angle is basically 3-dimensional angle, right? Plane angle is simply this angle we are familiar with. But if you have a surface, okay, then you want to measure the how much angle it makes, then it is called solid angle. Solid angle, you can imagine, it's a 3-dimensional angle. Okay, and its unit is steradian. Its unit is steradian. Radian is the unit of plane angle and steradian is the unit of solid angle. But remember, both of them are dimensionless quantity and they are called, so both solid angle and plane angle are dimensionless quantities and they are called supplementary units. Okay, supplementary quantity. Okay, they do not have any dimension and they are not a ratio of 2 similar quantities. That's why it is called supplementary quantity. Now let's move on with the fill in the blanks. Dash is a basic physical quantity. Let's see: strain, plane angle, temperature, frequency, significance. So out of this, only temperature is a basic quantity, basic physical quantity. So temperature will be the answer. Okay, so correct answer is temperature. Next is, in a number, the zeros between 2 non-zero digits are. In a number, the digits between 2 non-zero digits are are significant. So correct answer for this will be significant. Always after reading the question, always read the options carefully. This will be significant. Next, dash is a supplementary quantity. Now we already know, I have explained it, plane angle and solid angles are called supplementary quantity. So if you see plane angle is there, so here answer will be plane angle. Next is the physical quantity that has neither a unit nor a dimension. So if you see strain is the ratio of two similar quantities. So strain is a dimensionless quantity, so it has no unit and no dimension. So dimensionless quantity is strain. Now you might be confused between plane angle and strain, but remember, even though plane angle is a dimensionless quantity, it has a unit. Okay, very interesting, right? It has a unit of radian and in some sense degree also. So but strain does not have any unit or any dimension. It is a ratio of two different lengths. Okay, delta L by L. In the chapter mechanical properties of solids, you will learn more about strain. The physical quantity having the dimension m0 L0 t to the power minus 1 is. So t to the power minus 1 ml0, that means 1 upon t. 1 upon t means per second. So per second is also known as hertz. Okay, per second is the unit, so that is called hertz. Hertz is the unit of frequency. Okay, this is the unit of frequency. So correct answer for this will be frequency. Okay, make sure you read the fill in the blanks. Now obviously here we are doing from one single chapter. In the exam there will be 3 fill in the blanks from 3 different chapters. So read the options, read the fill in the blank statement carefully and try to make a sense out of it. If you just fill randomly, it will not make any sense and you will lose marks. So make sure that the sentence have a proper meaning. Okay, sense means the sentence have a proper meaning. If the sentence is not making any proper meaning, then most likely the option is incorrect. Now let's move on with our 2 marker section. Give any two limitations of dimensional method. Super important question. Number 1, it cannot determine the values of numerical that is dimensionless constant in equations. For example, numbers such as 1 by 2, pi or e that appear in many physical formulas cannot be found using dimensional analysis. Okay, so constant cannot be determined. So if your equation consists of some constant, so for example v is equal to ir, sorry, not v is equal to ir. Suppose I write an equation, say time period is equal to 2 pi, okay, square root of L by G. In that case, you will not be able to determine this constant using dimensional analysis. You will not be able to determine the constant using dimensional analysis. Even though you can find the relationship, you will not be able to find the dimension. Okay, I wrote something wrong over here. It will be G upon L. Okay, frequency is 1 by 2 pi square root of L by G. Anyway, so this is how you have to remember that constants cannot be determined using dimensional analysis method. It cannot be applied to formulas containing trigonometric, exponential or logarithmic function. This method only works for equations that are algebraic and consists of products or ratios of powers of quantities with dimensions. Okay, for example, if I say A is equal to B sin theta, this cannot be determined using dimensional analysis. Or say A is equal to B sin omega t. Okay, so this has a dimension. Omega and t both are dimension quantities with dimensions, right? But you cannot determine this equation using dimensional method. Only equations such as this, where say A is equal to B plus C, this kind of equations can be determined. And even addition is also not possible. Only multiplication, bx, suppose like that, can be calculated using dimensional method. Okay, addition also directly cannot be calculated using dimensional analysis. That is the third point. Now let's move on. State principle of homogeneity of dimensions. This is important. Principle of homogeneity means when you are writing an equation based on this, in KCET there are some MCQ questions in KCET exam, right, on the basis of principle of homogeneity. So suppose I am writing an equation, say x equals to y plus z upon a. So if I write an equation like this, you have to remember that first of all your left hand side's dimension and your right hand side dimension should be same. Okay, so left hand side whatever dimension is there, individually that dimension should be equals to y and z upon a. So all these dimensions should be same. So the principle of homogeneity of dimensions states that all terms in a physical equation must have the same dimensions, that is the dimensions on the both sides of the equation and in every term. So both side of the equation as well as each and every term in the equation should have the same dimension or identical for the equation to be physically meaningful. Remember that. So if this is not happening, then we will say that this equation is not possible. For example, if I say 1 kg per plus 1 meter, does it make any sense if I try to add 1 kg plus 1 meter? Okay, can you add them? You cannot add them because they are not dimensionally consistent. Okay, so remember that 1 kg plus 1 meter is not possible, 1 meter plus 1 second is not possible. Yes, 1 kg by 1 meter is possible. In terms of division it is possible, but when you are adding two quantities must have same dimensions, otherwise that equation is not possible. Division wise, multiplication wise it is possible, but addition wise the quantities must have the same dimension. That is also super important. Write any two rules for writing significant figures. Significant figures are super important. They can be asked as an example like this, or they can give you a number and they say how many significant figures are there. That is also super important. They might give you two or three options, two or three numbers, and they will ask you how many significant figures that does the number have, right? So that is also a possibility. So you have to remember all the rules. All non-zero digits are significant. For example, the number 456, all three digits 4, 5 and 6 are significant. Zeros between non-zero digits are significant. For example, in 4005, all four digits 4, 0, 0 and 5 are significant. There are other rules also. For example, in a decimal number, all zeros are significant, the trailing zeros are significant. If it is a non-decimal number, then trailing zeros are not significant. Okay, so for example, if I write 3000 point, all zeros are significant. But if I write 3000 only, then these zeros are not significant. Very interesting, right? Just this decimal changes whether they are significant or not. So even though this is not playing anything, any values are not changing, but that is changing the entire situation for zero, right? So whether you are having a decimal in your life or not, that determines whether you are significant or not. So that decimal point is super duper important. Don't forget about it, right? Now a 3-marker question. Check the dimensional correctness of the equation x equals to v0 t plus half at square, where symbols having their usual meaning. So we have to check the dimensional consistency. So what does that mean? So we have to find the dimensions of each side. First we will start with our left hand side. So what is the in our left hand side? Left hand side only x is there. So dimension of x is actually, what is the dimension? X means distance, so its dimension is nothing but L. Okay, so dimension of left hand side is x. Now we have to go into our right hand side, and right hand side we have two terms. So we have to check individually for each term what is their dimension. So first is term number 1. Okay, term number 1 is v0 into t. Now what is v0? v0 is velocity, right? So velocity, dimension of velocity is what? Dimension of velocity is velocity means distance by time. right? Meter per second is unit. So if you are someone who remembers the unit, back calculate it, or if you someone who remember the definition, you can go straight forward for it as well. So velocity is distance upon time. So velocity is distance upon time. What about t? T is time itself, so its dimension is capital T. So now simplify. So t cancels and you get dimension of L only. So now term number 2. So what about term number 2? If you see here we have half AT square. Now half is a constant. So only thing we need to find the dimension is AT square. Half is a constant. We will not consider any constant while calculating dimension analysis, right? So constants do not play any role over here. So A, what is A? A is acceleration. What is acceleration? Distance upon time square. Distance upon time square, meter per second square. So meter means distance, second means time, so meter per second square, or L upon t square in terms of dimension. What is t square? T square is again time, so it will be also t square. Now t square cancels, again you get dimension of L. So the equation is dimensionally consistent. You have to write this concluding statement. It will be dimensionally consistent. Okay. In case they give you some random equation and you find that it is not dimensionally consistent, then you have to write dimensionally inconsistent. Okay. So basically you are checking whether the equation is dimensionally consistent or not, or dimensionally correct or not. So you have to write dimensionally consistent or dimensionally inconsistent. On the other hand, you can write dimensionally correct, dimensionally incorrect. Both are allowed, right? But the concluding statement has to be written properly. Now let's move on with the next question. Derive the expression for period of a simple pendulum which depends on its length and acceleration due to gravity using dimensional analysis. Now this question have come from time to time as a 3 marker, as a 2 mark, as a 5 marker as well. 5 marker they might add one more question added to it. But yes, this question is being asked in PUC 1, especially FA-1 and midterm. This question is one of the favorite question of the examiners. So this question you might face. Okay. So how to solve this? So here we have time period which depends on length and gravitation that is given to you. But obviously that is not it. So you have to what is given, the time period depends on the length. Okay. Say to the power a. This a value is unknown. This a value is unknown. Okay. And time period is proportional to g to the power b. Okay. Depends on it. How it depends, that is not given. Okay. It depends on these two quantities. Now you have to figure out what is the value of a and b. Then the answer will be solved. Now when two quantities are individually proportional to a same quantity, so t is proportional to L to the power a, t is proportional to g to the power b. That means we can write t is proportional to L to the power a and g to the power b. And if you want to remove the proportionality sign, we have to introduce some constant L to the power a, g to the power b. Now this constant you don't need to find out. Obviously this constant cannot be calculated using dimensional analysis. So we just mentioned this is a proportionality constant. Okay, proportionality constant. Now let's move on and deep dive into our dimensional analysis. So now we will write dimension on our left hand side. Now here this is time period. Okay, time period. So dimension of time period is let me not write dimension of time period is t itself. Time period means seconds, 2 seconds, 3 seconds, 5 seconds. So dimension of time period itself is t, right? So one good thing. So dimension of time period t equals to constant we do not need to consider while doing the dimension analysis, only dimension of L. So what is the dimension of L? Dimension of L is length, so it will be L to the power A, and dimension of G. What is G? So you have to write that as well. Dimension of L is equals to third bracket L. A dimension is represented using third bracket. Third bracket means it represents dimension. Okay, and dimension of G, G is acceleration. G is gravitational acceleration. That means its dimension will be L upon T square, or in other words, we can write this as L T to the power minus 2. Right? So we have to use that here. L T to the power minus 2 to the power B. Right? Now simplify on the right hand side. Left hand side is very straightforward. If you see that L to the power A into L to the power B into T to the power minus 2B. This is the equation. Now when two quantities are multiplied, A to the power X into A to the power Y, we write this as A to the power X plus Y. Right? This is the way of adding indices. So we can write this as L to the power A plus B, T to the power minus 2B. Simple. Follow the steps. Do not need to remember or memorize anything. Follow the steps. You will be automatically getting the answer. You don't need to worry too much about it. Now, if you see that here, no length was there. No length there means L to the power 0. Right? Dimensionally, the equation has to be dimensionally consistent. If the equation has to be dimensionally consistent, that means whatever L value on the left hand side should be same as the L value on the right hand side. So here L is not there, so L to the power 0. So that means A plus B must be equals to 0. And if you see what is the power of T is 1 here, power of T is minus 2B over here. So 1 must be equals to minus 2B, or B must be equals to minus half. Okay, B must be equals to minus half. Now you use this value back in here. So A minus half equals to 0, or A equals to plus half. Right? So A will be equals to plus half. So from here you get the value. The time period is given by K, the constant K. Now we have to go back to this equation and put the value of A and B. L to the power half, L to the power half, G to the power minus half. You can leave your answer over here, or you can slightly write it L by G. To the power half means any quantity to the power half. So if I say A to the power half, that represents square root of A. And A to the power minus half means 1 by root A. Right? Plus half, root, minus half, 1 by root. Okay, so here both of them have root. One is plus root, one is division root. So square root of L upon G. Now you do not need to find or write the value of K. So this is the expression for time period for a simple pendulum. Right? Correct? So in the first part when I wrote the dimension of time period, first time I wrote correct, second time I made a mistake. Anyway, let's move on with the next chapter, motion in a straight line. So first chapter is done. Now let's move on with the second chapter. Second chapter onwards it will be slightly longer. Obviously first chapter is a little shorter, so we have finished it earlier. Now a body cannot have means it can have. So options, in the options there are 3 options that the body can have. Only one thing that it cannot have. So that cannot have we have to find. A constant speed and varying velocity. So let us understand constant speed and varying velocity. Suppose whenever we take example of velocity and speed together, we take the circular motion example. So a runner is rotating in a circular track with a constant speed. Okay, so a runner is running in a circular track in a constant speed, or a car is moving in a circular track in a constant speed. Okay, some racing track is there, but it is perfectly circle. It is moving with a constant speed. So each and every point, if you see, the velocity is different, because velocity is a quantity which is a vector quantity which has direction as well as magnitude. Magnitude wise the value of V is same, but direction is changing. So if direction is changing, then we cannot say velocity is same. Okay, velocity has to have the same direction and same velocity. Okay, so for example, if a car is moving in a straight path, okay, in that case, velocity and speed both are same. Okay, velocity, the direction is fixed, so the value of velocity and value of speed is same, and we will say that velocity is also constant. But in this particular case, even though the speed is constant, velocity is varying at each and every point. So we can say that a constant speed and varying velocity is possible in case of a circular motion. An acceleration and a constant speed. In this particular case also, there is a centripetal acceleration. You have studied in Newton's law chapter, right? So there is a centripetal acceleration and speed is constant. Again, that is also possible. Acceleration and constant speed is also possible. So for a vector and a scalar quantity can have different values. Okay. Uniform velocity and varying speed. Uniform velocity means this case where the velocity is at a fixed direction, so speed has to be same. Okay, the magnitude of velocity is the speed. So if the velocity is fixed, speed has to be fixed. Speed cannot change if the velocity is fixed. But yes, if the speed is fixed, velocity can change. Velocity is more independent than speed. Velocity, speed is same, velocity need not to be same. But if velocity is same, speed has to be same. So this case body cannot have this. So this is our correct answer. You have to logically explain each and every option before marking the correct option. This is a logical question rather than a more reading based question. Non-zero speed and non-zero acceleration is possible. Non-zero speed, non-zero acceleration in many cases. In a straight path also, non-zero speed, non-zero acceleration both are possible, right? So obviously option D is possible. Only thing that is not possible, uniform velocity and varying speed. So if the velocity is uniform, speed will also be uniform. It cannot vary, right? Now let's move on with the next MCQ. The slope of the tangent drawn to a position time graph at any instant gives. Suppose you are drawing a position versus time graph. The position versus time graph you are drawing. Suppose the position time graph like this. Now if you draw a tangent to the graph, let me use a separate color. We have a lot of colors here. So if you draw a tangent to the line, and if you take the slope of that tangent, slope means, what is slope by the way? So this is y, this is x, and this angle is say theta, then slope is tan theta equals to y upon x. In more accurate terms, we write it delta y, delta x. Now position time graph, if you see, position time graph along the y axis we denote the position. So this is basically distance traveled, distance, and along the x-axis we measure the time. So this is time. Okay, so this will be a form of speed, either speed or velocity, right? So when you draw a tangent to a position time graph, that gives you instantaneous velocity at that point. Okay, this basically gives you instantaneous velocity at that point. Okay, average velocity means you have to take the entire distance traveled and entire time taken. But tangent, when you are taking a tangent at a point and measuring its slope, that gives you the instantaneous velocity. That gives you instantaneous velocity. Remember this. Okay, tangent, whenever you are drawing a tangent and trying to calculate its whatever the slope of the graph, so tangent gives you instantaneous velocity. Okay, and area under the graph gives you the total distance traveled. No, not position time graph, velocity time graph. Area under the graph gives you the total distance traveled. Now here a graph is given here. The distance time graph for a particle in the motion as shown in the figure. The maximum instantaneous velocity of the particle is around the point. So here you have to find the maximum instantaneous velocity. So maximum instantaneous velocity. What is instantaneous velocity? Instantaneous velocity means velocity is changing. Suppose 10, 11, 20, 25, 31, then 27, 30, 27, 22, like that. So velocity is changing, right? For any object it can change, but at the particular second, whatever is the velocity, that is called instantaneous velocity. Now in physics, there is a way to calculate it from the position time graph or distance time graph. How to find it? I already explained that you have to draw a tangent and find dy dx or delta y delta x. Okay, so if you see here all the points, if you see for same delta x, delta y is very large for this point. Okay, what is slope? Slope is delta y upon delta x. Okay, delta y is our distance and delta x is our time. So if you see here for a same given time interval, here the y value is very high. That means this has the highest slope. So point C basically having, and A is basically 0. A is 0. Okay, so point C have the highest instantaneous value. So you have to draw small triangles in the graph and find for which triangle the y value is more. Okay, and as you can see, point C have the highest slope, so instantaneous velocity will be highest for point C. Now remember, options are given not in order. A, B, C, D. Do not mark option C. Only choose the correct answer, that is C. Correct answer is C, not the correct option is C. Okay, and that kind of question can confuse if you are. I have seen students, they try to answer, share their answers. Okay, and someone will say C. Okay, and the other one will say which C, option C, or correct answer is C. So that can create confusion, and that's why teachers may prefer to give you such kind of question. Okay, now next is when a body thrown vertically upward, it will take t time to reach its highest point. Then the time taken to return to ground is. So when you throw an object, if it is reaches to the highest point by time t, it will take the same amount of time to reach ground as well. Okay, so time taken to reach the top position and time to taken to reach the ground should be same. Okay, so here the answer will be T. It is a slightly cool question. Okay, you need to be careful and answer it properly. Next, there are the area under velocity time graph. So as I mentioned, if you are plotting velocity time graph, okay, the area under the graph gives you the total distance travel. We will use that. We will use this method while doing the graphical solutions. So just in a few minutes later. So by that time you should be familiar that area under velocity time graph gives you the distance traveled. Slope of velocity time graph gives you the acceleration, instantaneous acceleration. Okay, so this will be distance traveled, or you might say displacement. Velocity time graph means displacement, speed time graph, distance traveled. Okay, so if you are plotting velocity time graph, it will give you displacement. Okay, let's move on. Statement number 1, an object may fall with a constant velocity. This happens when acceleration of the object is equal to the acceleration due to gravity. Okay, an object may fall with a constant velocity. Velocity is constant. This kind of velocity is called terminal velocity. Okay, this kind of velocity is called terminal velocity. Now, object is actually accelerating with the gravitational acceleration only. So, the statement 2 happens when the acceleration of the object is equal to gravitational acceleration is not correct. When the force acting on the object is equal to the weight of the object, then only the body can fall with a constant velocity. If the force that is acting on an object is exactly equal to the weight of the object, that means the drag force. It is called drag force. We will learn more about it in the future chapters, but for now you remember whenever an object is trying to fall through air tries to resist it. Okay, and because of that resistance, there is a force that is acting on that object, that is called drag force. If you have seen paragliders or parasailers or the parachute, use of parachute is based on that fact. Okay, so when the parachute is being opened, so basically that means what happens is that the air resistance decreases its velocity and it attains a terminal velocity, a constant velocity. It is no longer accelerating towards the ground. Okay, that is the main reason parachutes are used. Okay, so statement number 1 is true, this is true, this is false. Okay, so statement 1 is true, but statement 2 is false. So option C is correct answer. Next, fill in the blanks. The shortest distance between initial and final position of a body is called, the shortest distance. Suppose a body moved like this. This is the shortest distance. This is called displacement. This is called displacement. So this will be displacement. Now, whenever you are doing the fill in the blanks, always mark or underline whatever is correct. Okay, whenever you are answering one correct answer, always try to underline, so that when you are doing it for the next one, you should not look for the incorrect one. Okay, speed is a dash quantity. Speed is a scalar quantity. So if you see, it is scalar is mentioned, only scalar is mentioned, so we have to write scalar. Speed is a scalar quantity. Next, if a body has equal changes in velocity in equal intervals of time, the body is said to be uniform acceleration. If the change in velocity is uniform, then it is called uniform acceleration. If the change in velocity is 0, then it is called uniform velocity. Okay, so if they add one more option, uniform velocity, don't fall for the trap. If velocity is 0, change in velocity is 0, then it is called uniform velocity. If the change in velocity is constant, then it is called uniform acceleration. It is called uniform acceleration. Okay, next, the slope of position time graph of a body in uniform motion gives. Now, if the uniform motion, if the motion is uniform, okay, suppose position time graph is like this. If you are finding the slope at any point, it will not only give you instantaneous velocity, it will give you the velocity itself, because velocity is uniform. That means velocity is not changing. So instantaneous velocity is here, 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 at every point it will be same. So it will give you directly the velocity. So no need to write instantaneous, it will be velocity. So this is a trick question, just to trick you, that you know that slope of a position time graph gives you instantaneous velocity, but if the velocity itself is uniform, then you get the directly the velocity, you don't get the instantaneous one. Instantaneous is same. So velocity is also done, uniform acceleration is also done, scalar one is also done. So last is left, a body moving under Earth's gravitational field, the direction of acceleration is always downwards. Only one option is left, so this will be downwards. Okay, clear? To fill in the blanks, the strategy should be, first see if you know the answer. Okay, if you know the answer, write it down. If you don't know, or if you are confused, try to fill up whatever answers that you already know, fill them up and leave the unknowns for the last part. And if you are still confused, make sure that the options which are given, generally they give one extra, but here we do not have one extra. Okay, so that can be tricky. Now, if they are giving one extra, then you have to see that whether it is making any sense. The word is making, the sentence itself is making any proper sense or not, or proper meaning or not. If I write, the body moving under Earth's gravitational field, the direction of the acceleration is always velocity, that does not make any sense. Direction cannot be velocity, right? Or if I say direction is always uniform acceleration, that also does not make any sense. So make sure that sentence is complete, it is making a proper meaning, then only that could be a possible option, right? In some cases they give you options where can be very close to each other. Other than that, so there will be out of the 5 out of the 3 fill in the blanks for FA1. In the final exam, there will be 5. So out of the 3 in FA1, 2 can be solved directly. 1 could be confusing, but make sure you read that question carefully and solve that. Okay, reading is very important. Don't just rush with the fill in the blanks and MCQ question. Let's move on with the 2 marker. Write 2 differences between instantaneous speed and instantaneous velocity. So what is instantaneous speed? Instantaneous speed is the magnitude of how fast an object is moving at a particular moment without regard to its direction. Okay, that is instantaneous speed. Okay, it's scalar quantity. Unit wise, both the quantities have same units, so do not write units. So instantaneous speed is at particular instant. What is the change in its distance traveled with respect to time. Okay, so instantaneous speed is the magnitude of how fast an object. So magnitude of how fast an object is moving at a particular moment, right? So this is called instantaneous speed, whereas instantaneous velocity is the speed of an object at a particular moment along with its direction. So now, because we have defined speed, we are taking the help of speed and adding a direction, and that is called instantaneous velocity. Velocity is a vector quantity. Okay, now let's move on. This diagrams, drawing the diagrams are also very important. Draw position time graphs for a body moving in a positive direction with negative acceleration, positive acceleration, constant speed. Position time graph for these 3 are super important. They can ask you any 2 of them, or all 3 of them can be asked as well. So here, this is the negative acceleration. Negative acceleration goes down like this. Okay, positive acceleration goes up like this, and constant velocity is straight line. Okay, constant velocity, it's a straight line. Position time graph, so it is not this straight line. Okay, it will be a straight line passing from origin generally. Okay, it can be straight line like this also, but yes, for most convenience we are not showing this. But remember, many people, many students draw wrong. They draw negative acceleration like this. Okay, this is not negative acceleration. Okay, this is not clear. Some draw positive acceleration like this. This is not positive acceleration. Okay, make sure you are drawing it properly. That is very, very important. Okay, I have tried to give you the most clear cut diagrams in the textbooks, and in many other reference books these diagrams are not given properly. That's why I have tried to given you the proper diagrams simulated to software. Okay, here this is position, and this axis is time axis. This is time axis. This is time. Okay, here this time is mentioned anyway, right? Now let's move on to the next question. A body moving with an initial velocity 5 meter per second and uniform acceleration 1 meter per second square, determine its velocity after 20 seconds. Okay, initial velocity is given, acceleration is given, time is given. They are asking you what is the final velocity after 20 seconds. So this can be asked as a 2 marker small numerical. It can be asked as a 3 marker small numerical as well. So what formula to use? V equals to U plus AT. I hope you use the same symbol. Some books use this is like V is equal to V naught plus AT. Okay, I use V is equal to U plus AT. Instead of V naught writing V naught, I use U. Okay, U is initial velocity. Initial velocity U is given by. So you have to declare or write the variables properly. Otherwise, obviously, you will not going to get marks if you just write the equation and solve it. So you have to declare what are all those. This is initial velocity. Okay, initial velocity. Okay, acceleration. A equals to 1 meter per second square, time t equals to 20 seconds. Now you can use these values back into this equation. This is called equation of motion. Equation of motion. Okay. So now we put the value 5, V equals to 5 plus A is 1 and T is 20. This will be 25 meter per second. Again, unit is mandatory for all kind of numericals. Final answer should contain the unit, otherwise no marks. Okay, remember that final answer should contain unit. And don't confuse with half at square, etc., etc. There are three equations of motions. V is equal to u plus at, v square is equal to u square plus 2as, and s is equal to ut plus half at square. Now, based on which data is given to you, you have to use any one of the equation, right? Let's move on. Derive the expression v is equal to v naught plus at using velocity time graph. This is a 3-marker derivation that is also possible from time. If they are not giving a 5-marker derivation, then they might give you a 3-marker derivation. Either 3-marker derivation or 5-marker derivation is going to come from this chapter for sure. So here it is mentioned that velocity time graph is given. So the diagram will be like this. Okay, and then you have to divide it into 2 parts. Okay, this is triangle part 1, this is the rectangle part 2. Okay, so initially the object, you have to describe the diagram, initial and object starting with the velocity v naught. You can write u also. If the question asks you v naught, you have to use v naught. If the question is asking u plus at, you use u only. Okay, so v naught is the initial velocity and it started accelerating with an uniform acceleration and it reaches to point B after a time small t. Okay, so this is the main statement that you have to write. Object starts with an initial velocity v naught and accelerates uniformly and reaches point B after time t as shown in the diagram. Okay, so this writing is common. We will be doing a few more derivations on this same diagram, but this is common writing for all derivations. If you are not writing it, you will lose marks. Okay, make sure you describe your diagram. Okay, so an object starting from A with initial velocity u reaches point B after uniform accelerating for time t. Right now, what is acceleration? Acceleration by definition acceleration is slope of the line AB. Acceleration, because it's uniform, if you can find the slope of this graph. Slope means, what is slope? Slope is tan theta. Tan theta means, what is tan theta? Some people have curly brown hair turned permanently black. This is a mnemonic. You can remember other mnemonic also. So perpendicular by base. So this is your angle theta. Perpendicular is this one and base is this one. So perpendicular by base is your acceleration. Okay, so that is v minus v naught upon t. V minus v naught upon t, that is the definition of acceleration, that is equals to A. So v minus v naught equals to AT, or v is equal to v naught plus AT. So hence proved or hence derived. So this derivation is very small, but remember the description, the diagram has to be drawn. Without diagram, because it's a graphical derivation, without diagram you will not get any marks, 0 marks. If you do not write the description of the diagram, you will lose 1 mark. Okay, and that is true for all other 5 upcoming derivations where we will be going to do 5 marker derivation. Now let us continue with the discussion. Next question, mention 3 applications of velocity time graph. Another super important question. Calculate the acceleration, slope, velocity time graph. So calculating acceleration. So velocity time graph, basically what is velocity time graph? So if you plot the graph, suppose this is the velocity time graph, how the velocity is changing over time. So basically if you want to calculate at any point, you just draw the slope, that will give you the acceleration. So slope gives the acceleration at any point. Determining displacement, if you can calculate the area under the graph, that gives you displacement. Analyzing the motion changes. So velocity time graphs helps visually identifying changes in motion, such as when the object was speeding up, when the object was speeding down. So for example, as you can see here, the object was speeding up, then it is almost constant, then again it is speeding up. So visually understanding how an object has moved in last throughout its journey, that is important, right? When for example you are scoring say 80 marks in your class 10th pre-board, then 90 marks in your final exam, and now suddenly you are scoring 45-50 marks in your PU1 exam. That means your graph was going up, now suddenly it comes down, right? So basically the marks helps you to identify how well you are performing in the exam. Similarly, velocity time graphs helps to identify when the object was moving with faster speed, when the object was moving with smaller speed, etc. Right? So that is also super important to know. Now let's see another numerical question. A car moving along a straight road with a speed of 126 km per hour is brought to a stop within a distance of 200 meters. What is the retardation of the car? Retardation means negative acceleration. So when the car speeds up, it calls acceleration. When the car slows down and stops, that is called retardation. Right? Now here the speed is given in kilometer per hour. So that can be tricky if you don't know. So velocity or speed symbol is same. It is given 126 kilometer per hour. Now, this is not SI unit, and in the next line it is mentioned that the distance that it traveled before coming to a rest is 200 meters. Okay, and you have to find the final velocity. This is actually u. I made a mistake. This is the initial velocity. Final velocity is 0. Obviously, it is coming to a rest, means final velocity is 0. Now you have to calculate the retardation or A. Okay, basically negative A. Now problem is here the unit is kilometer per hour. How to convert it into meter per second? To convert kilometer per hour to meter per second, you don't need to do too much. Only thing that you need to remember is 5 upon 18. 5 upon 18 meter per second. This is the conversion factor. 1 kilometer per hour equals to 5 by 18 meter per second. Okay, so if you multiply by 5 by 18, you will get the kilometer per hour value. Let's simplify. It will be 6 2s are 12, 3, 9, and it will be 7 9s are 63. So it will be 35 meter per second. Okay, so u is calculated. Now v is 0. Which equation to use? That is main important part. Here we will be using v square equals to u square minus 2as. Why we are using this equation? Because v is known, u is known, a we are trying to find out, and s is also known. And why there is a negative sign? Because it's retardation, that means negative acceleration. That's why u is here it is minus. So here we have 0 equals to 35 whole square minus 2 into a into 200. Okay, so from here we get 35 whole square equals to 2 into a into 200, or a equals to 35 into 35 divided by 400, right? 2 into 200 is 400. Now you can simplify this. It will be approximately 35 into 35 divided by 4. So 9, 4 9 is 36, 36, 9 into 35 to 70, 70. You can use the calculator obviously, but I don't like to use calculator. That's why I'm trying to calculate it using my head. 270 plus 45, 310. Approximately it will be 3. Second, 315 by 100. That is 3.15 meter per second square. Okay, 3.15 meter square. That will be the approximate value, right? Now again, it is an approximate value. You don't need to. You can use your calculator to calculate the exact value and write down the equation. But I recommend that as much as possible, do not use calculators. Use the calculator only at the last stage. Use the calculator only at the last stage, so that all in whatever can be cancelled are already cancelled, and you are good to go with only the multiplication and division part, right? Let's move on. With the derivation, derive the expression x equals to vt plus at square using velocity time graph. So as I mentioned, the write-up, initial write-up for this should be same as what we have done in the v is equal to u plus at derivation, right? So in the same way, you have to in this derivation also you have to show that acceleration is coming out to be v minus v naught upon t. This is the slope, and from the slope acceleration up to that point where you have calculated acceleration is common for this derivation. You have to reach over here, okay? And from here actually that your task is to calculate the v, okay? And you will get v is equal to, from here you will get v is equal to v naught plus at. You can use this as a equation of motion, but because it is given in the from the graph, you have to do it using the graph mechanism only. The exact statement that I have written for that other question, you have to write it over here as well, right? Now what? So x equals to v naught t plus at square. What is x? X is displacement. Now we know that displacement is equals to the area under Vt graph. So up to that point, whatever we have done has to be done, and then we have to come to this part where we are calculating x. The initial part is common in the derivation that we have done earlier as a 3 marker, right? That is also super important. That's why I am saying. Okay, x equals to displacement, that is area under Vt graph. So area under Vt graph means this is the Vt graph. Area under Vt graph is this one. Okay, and as you can see here, we can divide this area into two parts. One is this rectangle, okay, and another one is this triangle. If you know the area of a trapezium, also you can use that as well. Okay, now here for most of the students, for benefit of most of the students, I will be using this rectangle and this triangle. So this is basically area of the rectangle ACDO plus area of the triangle ABC. Okay, so what is the area of a rectangle? Area of a rectangle is length into breadth. So what is length over here? Length is time t. So length is time t into what is breadth over here? Breadth is this one, that is that is V naught. Okay, plus what is the area of a triangle? Area of a triangle is half base into height. Half base into height. Base is T, height is V minus V naught. So this is our equation of this displacement. So we have calculated x, but this is not on the form that we are looking for. This is not exactly the form that we are looking for. So we have to adjust it. Rather doing this, what we can say is AT equals to V minus V. This is what we need. Okay. Now, why? Because basically in this expression, if you see, there is no V. V is missing in this equation. So we have to replace V over here. Now you can replace, take the value of V and put it over here and make the things complicated, but there is a easy shortcut that if you put the exact value of V minus V naught in this, your answer will be done. Okay, so this is your equation, say 1. Now substituting AT equals to V minus V naught, we get x equals to V naught T, obviously T into V naught is V naught T, plus half into T into what is this? A T, right? V minus V naught. So this is much easier and simpler without doing a lot of different difficult mathematics, and you get half AT square. T into AT is AT square, so x equals to V naught T plus AT square, hence proved. This is the derivation. Easy derivation, not a difficult derivation, but you have to practice it, obviously. Now next, derive an expression V square equals to V naught square plus 2ax using V minus T graph. So again, the derivation part is same, and we have to do the same thing, that is V minus V naught upon T equals to A. Now here if you see that the major difference in this equation, time T is missing. Time T is missing. So in this case, what we will be doing? We will be finding time T. So T equals to V minus V naught upon A. Cross multiplication, T goes up, A comes down. So this is cross multiplication is happening. So basically we are the same derivation wise. I am again saying that this part of the derivation is common. The simple 3-marker derivation or a 5-marker derivation up to this much is common for all derivation. Okay. Now here, because time is missing, we will find time from this equation, and again we will be using the same formula. X equals to the area of the rectangle, ACOD, sorry, and plus area of the triangle ABC, and AOCD is V naught T plus it will be half T into V minus V naught. Okay, so this is the first step. Now here what you have to do, you are trying to replace this time T, so you have to simplify a little bit. How to simplify? Take LCM 2 and you get 2 V naught T plus, or what one thing you can do is take T common outside, so 2 V naught plus V minus V naught. Okay, basically this is coming out over here, and we have taken this 2 as common LCM. Now do cross multiply. 2x equals to 2 V naught minus V naught is V naught, so V naught plus V into T, right? So this is the equation that we are getting. Now we have to substitute this T with this equation. Okay, so you can write V plus V naught plus, if we interchange does not matter, V minus V naught by A. Okay, so this is our equation 1 in this case. So from equation 1. Okay, so this is the major part. majority is done. Now only mathematics is left. So this A was in division, do cross multiply, and we can write 2ax equals to A plus B into A minus B, that is V square minus V naught square, or V square equals to V naught square plus 2ax. This is the derivation. This is the derivation of area under the graph for this particular, this is the equation of motion for this particular equation using graph. Okay, using graph, the initial part is common, how to calculate x. Now how you treat afterwards is different. So here you have to eliminate time. In the previous one you have to eliminate v. Okay, and eliminating v is easier if you directly eliminate v minus v naught altogether, right? So just go through this derivation twice and you will be sorted for one derivation. Now numerical question, a body projected vertically upwards with a velocity of 15 meter per second from the top of a tower reaches ground in 5 seconds. Find the height of the tower. So first of all, understand this question. You have a tower, and from the top of the tower you are projecting a object upward, okay, with a speed of 15 meter per second, and after it goes up to reaching the maximum position and then it coming back, and this entire thing is happening in 5 seconds. You have to find what is the height of this building. Okay, you have to find what is the height of this building. Can be tricky if you are not able to understand the question. So when you are throwing a ball from the top of the tower, you are throwing it upwards. Okay, so it is first going up from the top of the tower, then it is coming back, and the entire process it is taking a time of 5 seconds. Okay, so now this problem can be done a multiple way. Okay, first of all we have to find out how much height it will travel, or how much time it will take to reach, go up and come down like this, right? And when the ball reaches over here, because you have thrown it with 15 meter per second, it will come back with a 15 meter per second as well. Now whether all the information we need will be used over here or not, that we have to figure it out. Okay, so now let's see. So first, this is u, okay, and at the top position velocity is 0. When it is reaching the top position, velocity is 0. So we will be using, and what is the gravitational acceleration? Gravitational acceleration is always acting downward, and we will be taking that as 10 meter per second. So let's find out how much time it will take to reach the top. The time it will take can be calculated. Final velocity is 0. So we will be using v is equal to u plus at. Okay, first case number 1 going up, it will be 0 equals to 15 meter per second minus g into t. Why minus? Because when the ball is going up, the gravitational acceleration is acting downward, so it is negative acceleration. Okay, so from there we can say that 15 equals to 10t, or t equals to 1.5. So the object is taking 1.5 seconds to reach the top. Okay, it is taking 1.5 seconds to reach the top. The height of this portion is not required, because as I mentioned, when the ball reaches the top, its velocity will be 0, and if it is taking 1.5 seconds to reach the top, it will take another 1.5 seconds to reach at the same height of the building. Okay, so 1.5 seconds it will take to reach the top, then another 1.5 seconds it will take to reach the same height of the building. So total time is 2t, that is 1.5 into 2, that is 3 seconds. Now from here onwards, the ball is falling with the velocity 15 meter per second. As I mentioned, conservation of energy. If you throw a ball with 15 meter per second, it will come back with the same velocity downward direction, right? So from here, the ball has a speed of 15 meter per second, but it is downward, so it is accelerating, and moreover, the time taken from here to here will be 5 minus 3, that is 2 seconds. Okay, now we have all the parameters. we can find the height. H is equal to ut plus half at square. Okay, so this is the parameter, we have simplified it. So what is u? U is 15 meter per second, time is 2 seconds, right? Not 5 seconds, not 3 seconds, 2 seconds, because 5 seconds is entire journey. Out of that, it only spends 3 seconds when it is on the top of the building itself. Remaining 2 seconds, it reaches the ground, and as I mentioned, because it is thrown with a 15 meter per second, it will come back to the same height of the building with 15 meter per second as well, plus half into g into 2 square, right? So 30, 15 to the 30 plus half into 10 into 4, that is 2 cancels, and we get 30 plus 20, that is 50 meter. Height of the building is 50 meter. Okay, even though the problem looks difficult, this is step number 1, this is step number 2. Okay, now even though the problem looks difficult, if you are understanding the concept, it is not a very difficult problem. You can solve this kind of questions in multiple ways. I have shown you one of the way. A body let fall from the top of a tower covers 45 meter in the last second of its fall. Find the height of the tower. Now here again a tower based question. Here we have a tower. Okay, some tower is there, and the ball, when it is falling from here, it is just dropped. Okay, it is not given any initial velocity. So remember, initial velocity here is 0. It is fall from the top means it is just dropped. Okay, it is not being thrown. So initial velocity is 0, and when it is accelerating, it is accelerating with gravitational acceleration. Last second of its fall, okay, in last 1 second, it travels 45 meter, and they ask you what is the height of this tower. What is the height of this tower? Okay, now how to solve it? So suppose the ball takes t seconds to reach the ground. Okay, the ball takes t seconds to reach the ground from starting from top till bottom. Total time is t seconds. Okay, total time is t seconds. We can write h is equal to ut plus half gt square. Now obviously u is 0, h can be written as half gt square. Okay, this is the total height of the building. Now how much distance it will travel in last 1 second? So how much distance it will travel in last 1 second? That is another important question. Suppose this distance is, obviously what is this distance? H minus 45. Okay, h minus 45. So h is the total height, so this must be h minus 45, and this much time taken to cover this much is t minus 1 second. Okay, or you can say, okay, say this height is small h and time taken to cover is t minus 1. This is also okay. Now let us figure out what is h. H is same formula, half g, only t minus 1 whole square. So starting from 0 in t minus 1 second, how much distance it will cover? It will cover half g t minus 1 whole square. Now what is the difference? Difference is h minus small h. Okay, and that is given by half g t square minus half g t minus 1 whole square. Obviously the difference of h minus h is this, that is 45 meter, which is given in the question. So 45 meter equals to half g is common, you get t square minus t minus 1 whole square. Okay, t square minus t minus 1 whole square. Now let's simplify. Half g t plus t minus 1 into t minus t minus 1, then minus minus will be plus. Just be careful with the signs. Okay, you get half g 2t minus 1 into 1, or half into 10 into 2t minus 1, that is equals to 45. So 5 cancel, 5 9s are 45. So 9 equals to 2t minus 1, or 2t equals to 9 plus 1, that is 10 seconds, or t equals to 5 seconds. Time is calculated. So time is calculated. Now next part is what? Is calculate height. So now we go back in this equation again, or rather this equation. So h equals to half 10 into 5 square, that is 5 into 25, that is 125 meters. So height of the tower is 125 meters. So first you take see that how much distance is traveled, or how much distance is traveled when it is falling from the rest. In total interval, the distance is obviously height of the building, and how much distance it travels in t minus 1 second. Same formula. Okay, basic idea is that we can start with the same formula, only keeping the time is different. Okay, time is different, but formula is same. Now it says that last second itself it travels 45 meters. So last second, so till suppose it falls for n seconds. Okay, till n minus 1 second it had traveled say 100 meters. Then total distance difference between these two has to be 45 meters to be exact. So h minus h is 45. Okay, and then you put those values in the equation, simplify it, and you will get the answer. Okay, so understanding the problem carefully is important. Okay, you just cannot solve numerical questions without understanding. Just reading the question and writing bunch of equation will not help. Understanding is very, very, very important. That okay, so this is the visualization also, and for visualization always draw diagrams to understand what is happening, what time, when the object was there. Okay, so that is super important. Understanding a diagram or drawing a diagram, understanding the problem is super important, and this is the habit. You cannot do it in 1 day or 2 days. Okay, unless and until it's a formula based question, you will always struggle if you are not making this a habit. Every day, every time when you are solving a chapter, immediately solve the in chapter questions as well in NCERT textbook. That will build your concepts. Okay, now let's move on to motion in a plane chapter. As usual, we will start with MCQ questions first. Which of the following is not a vector quantity? Which of the following is not a vector quantity? Work, displacement, impulse, momentum, all of them are vector except work. Work is a scalar quantity. Next, if a vector is multiplied by a positive scalar, the resulting quantity is a scalar having, so if you multiply a vector with a positive scalar, the quantity will remain same, magnitude will increase, but the direction will remain same. Okay, a vector having same direction as initial vector. So if you multiply a vector quantity with a scalar quantity, it will still remain a vector. Its magnitude will increase, but direction will remain same, and it will still be a vector quantity. Next, the resultant of two vectors acting at a point is minimum if they are in the same direction, perpendicular to each other, making an angle 120 degree with each other, opposite to each other. So if you are considering two vectors, say A vector and B vector, okay, if they are acting in the same direction, they gets added up. Okay, but if they are acting in the opposite direction, then it will be A minus B. Okay, so if they are acting in the opposite direction, then only the resultant is minimum. Resultant is not minimum at 90 degrees. Obviously at 0 degree they are maximum, and at 180 degree they are minimum. 0 degree means they are in the same direction. If A and B are in the same direction, okay, then their angle, they are in the same direction, so angle in this case is 0. Okay, angle when they are opposite direction, they are 180 degrees. This is the condition for minimum. This is the condition for maximum. Okay, so there are few questions where they will say 5 and 8, the vectors having values 5 and 8, what is the maximum and minimum possible values? Maximum will be 5 plus 8, minimum will be 8 minus 5. Okay, that's how you can find the maximum and minimum values. So opposite to each other is when their value is minimum. Next, statement number 1, vectors addition is commutative. Statement number 2, two vectors may be added graphically using triangle law of vector addition. Okay, so both statements are true and statement 2 is correct explanation of the statement 1. So vector addition is commutative. What is the meaning of commutative? Commutative means if you are doing A plus B, okay, and if you are doing B plus A, it does not matter which order you are adding them. A plus B or B plus A, the resultant will always be same. That is called commutative. Okay, so if you reverse the order, flip the order, okay, 5 plus 2 is 7, 2 plus 5 is also 7. This is commutative. In case of vector also, even though we consider direction, it does not matter which vector is first, which vector is second. Okay, now let us figure out the triangular law. Triangular law says that the vectors may be added graphically using the triangle law. So triangle law says this is A vector, this is B vector, okay, and the resultant of A plus B is this vector. Rightly. Okay, so basically what does this mean? If you are drawing two vectors starting from a point, and if you complete the triangle with the third arm, okay, starting from this point to this, okay, you are supposed to get the first vector. Now if you draw this vector first, okay, you draw this vector first, you draw the second vector first, okay, sorry, you draw the first vector and then you draw the second vector, you will still get the third vector in the same direction. It does not matter how you are adding them, okay, as long as the angles etc. These conditions are satisfied, okay, you will always get that third vector will be on the same direction. Now vector addition being commutative can be proven by the triangle law, okay, if you are drawing two vectors back to back, the third side proves the but it is directly not related. So both statements are true, but statement 2 is not correct explanation. Both statements are true. Obviously this is correct statement, this is correct statement, but they are not directly related to each other. That means both statements are true, but they are the statement 2 is not correct explanation of the. So if it was like this, then it would have been not mattered okay, because it is actually coming from the geometry, okay, it does not matter the order, okay, and that cannot be explained using triangle law, right? So we basically say that both statements are true, but statement number 2 is not correct explanation of statement number 1. For maximum range for a projectile, the angle of projection should be. So for maximum range of a projectile, so if you want to get a maximum range, the angle of projection should be 45 degrees. Okay, maximum for maximum range, the angle of projection should be 45 degrees. Next, for maximum height of a projectile, the angle of projection. Interesting question. For maximum height, okay, when you project this, you might be very tempted to mark 45 degrees, but for maximum height, the projectile should be thrown vertically upward. If you throw something vertically upward, it rises to the maximum height. So that means the angle of projection will be 90 degrees. Okay, so remember that for maximum height, it will be 90 degrees, but for maximum range, it will be 45 degrees. Okay, next, fill in the blanks. A vector with zero magnitude is called dash vector. So vector with zero magnitude is called null vector. Is there a null vector option? Yes, null option is there. So we will write. Okay. The splitting of a vector into two or more components are called dash of a vector. So, splitting of a vector into two or more components are called resolution of vector. Called resolution of vector. Okay. The resultant of two vectors is maximum if they are acting in the same direction, right? Angle theta 0. So, that means they are acting in the same direction. Okay, same direction. Next, dash velocity remains constant throughout the motion of the projectile. So, when you are considering a projectile motion, okay, the horizontal component of the velocity remains constant. So, horizontal is the answer. So, horizontal velocity remains constant. Next, in uniform circular motion, the body moves in a circle with constant speed. It moves with a constant speed. Okay. So, in uniform circular motion, the body moves with a uniform speed. Let's move on. Two vectors of same units have magnitudes 9 and 5 units. What are the maximum magnitude of the resultant that can be obtained with the two vectors? So, here they have asked you maximum and minimum magnitudes. So, maximum for max magnitude, okay, theta must be 0. So, that is given by r is equal to 9 plus 5, that is 14 units. Okay, and for minimum, okay, theta must be 180 degrees. Okay, then it will be, resultant will be 9 minus 5, it will be 4. Okay, so for maximum it will be 14, for minimum it will be 4 units. Move on. Write the expression for resultant of two concurrent vectors A and B. Explain the terms. Okay, so resultant of two concurrent vectors. Concurrent means they are actually, suppose this is A vector, this is B vector. They are acting on the same point. Then they are called concurrent vectors. So, what is the formula for resultant vector? It is given by square root of A square plus B square plus 2AB cos theta. Okay, where angle between them is theta, and tan phi is the angle that you are measuring. Suppose you are using parallelogram law. This angle is phi. With respect to which side you are measuring the angle? You are measuring the angle with respect to B. So, it will be A plus B sin theta divided by B cos theta. Okay, so this is the resultant of the angle between the two vectors, and you have to explain what is angle theta, what is this, okay, and this is the expression. You have to write the angles as well. Okay, you just simply cannot write the only the tangent, only the resultant. Okay, angle also has to be written. What is meant by the range of a projectile? Give the expression for the same. What is the angle of projection for which the range of the projectile is maximum? Okay, so the range r of the projectile is in the horizontal distance it covers from the point of projection to the point where it lands on the same horizontal level. So, r equals to u square sin 2 theta upon g. The range of is maximum for theta is equal to 45 degrees. So, basically you have to write everything in one place. Explain the triangle method of vector addition. In the triangle method of vector addition is a graphical way to add two vectors by placing them head to tail in sequence. So basically you are doing, and if they ask you triangle method, diagram is compulsory. So this is the head of the first vector, this is the tail of the second vector. So this is called head to tail, and this is the resultant. So this angle is theta. Okay. Draw the first vector within the tail of the standing point. I think I wrote one thing very wrong. It will be A sin theta by B plus A cos theta. Okay. I just realized it while doing the triangle method. Okay. So this is the triangle method. So this is, suppose, vector A. This is vector A. This is vector B. This is the resultant R. Okay. Draw the first vector with the tail at the starting point. Draw the second vector from the head tip of the first vector. The resultant vector is the side of the triangle that connects the tail of the first vector to the head of the second vector. So that vector which connects the tail of the first vector with the head of the second vector, that gives you the resultant vector. Okay, so you have to draw and explain this. Very important to remember it. Okay, next, derive the expression for time taken to reach maximum height by a projectile. Okay, so when so remember, this is the starting of the projectile journey. We will do a lot of derivation based on projectile. So suppose we have thrown a projectile with a velocity say v. Okay, so it has two components. One component is along x direction, which is obviously, if this angle is theta, this is v cos theta, and this is v sin theta. Now obviously when you throw a projectile, it moves something like this. Okay, and while it is in motion, its horizontal velocity remains constant, vertical velocity changes. Okay, to find the time taken by the projectile, we will only consider the vertical component of velocity. We ignore completely this portion. We will assume that as if the object is rising up and coming down, only using this velocity. Why we do the resolution of vector while doing solving projectile based problems? Basically this helps us to differentiate between these two kind of motion. Okay, this object is moving in the horizontal direction. So if this object is moving in the horizontal direction and this is moving in the vertical direction, they are two perpendicular motion. That means they are independent of each other. They are independent of each other means we can treat them separately. We do not need to combine them from the beginning. So when we are treating the only the vertical component, we will only focus on vertical component. So object is basically, you throw up an object, is going up and coming down, and the velocity is v sin theta, not v sin theta. So velocity is changed, but we can assume this motion to be only vertical motion. Horizontal motion is not included in this case. Okay, so that is why we use resolution of vectors. Resolution of vector, when we are doing two perpendicular vectors, they can be considered independent from each other. Okay, now let's start with v sin theta. So for vertical motion, what is happening? Initial velocity u is v sin theta. Now, after time t, it reaches maximum height. Okay, maximum height h. So when it reaches the maximum height, at maximum height, final velocity is 0. When you throw something up, what happens at the top? So when it reaches the exactly at the top position, at the top it's momentarily stopped, right? So when you throw it, okay, so at some point it momentarily stops and then it falls back, right? So at maximum height, v is equal to 0. Now we will be using the equation V is equal to U plus AT. Now here remember object is moving outward, gravitational acceleration is acting on it downward. So in that case, excuse me, 0 equals to V sin theta minus G into T. Okay, or V sin theta equals to GT, or T equals to V sin theta upon G. So this is the time taken by the projectile to reach the maximum height. Total time of the projectile, total time is nothing but given by twice of this. So by the time projectile is going up and down, it is reaching its destination along the horizontal. Okay, so by the time you throw the ball, go up and down, there is a also horizontal component which is taking it forward as well. So do not think it is a complex motion, think it as if the two different motions happening parallelly. One way it is going up and down, and another way it is going horizontal direction. So by the time ball goes up and comes down, okay, some other magical thing is actually taking it in the forward direction as well. That magical thing is its horizontal motion. Okay, so this is the total time. If they ask you total time, just remember total time of projectile or total time of flight is twice of this time. Okay, move on. A stone of mass 2 kg is tied with a string of length 1.5 meter, is rotating in a circle with a constant speed of 10 meter per second. Calculate its centripetal acceleration. So centripetal acceleration is given by V square upon R. As simple as that, simple formula, put that and calculate it. So V is given in 10 meter per second. Okay, and radius of the motion is given 1.5. Nothing, no need to convert anything else also. So 10 square by 1.5, right? Diameter is given or length? Okay, length is given. So if you are rotating an object in a string, that means that is actually the radius. Okay, if they give you the diameter, then you have to divide it by 2 to calculate the radius. Diameter is not given. So when you rotate, after you tie a rod or tie a stone into a string, and when you rotate it, the string itself is the radius of the rotation. Okay, it will be 100 by 1.5. So 0, another 0. Okay, this will be 15. 3 5s are 15. 5 2s are 10, 200. So it will be 180, that is 66.66. Okay, so this will be 66.66. So the centripetal acceleration is 66.66 meter per second square. Okay. Now, next question. Show that the trajectory of a projectile is a parabola. Now move on to the 5-marker question from this chapter. First question, the most important question, show that the trajectory of a projectile is a parabola. The most important question from this chapter in terms of 5 marks derivation. Now what is, how to show trajectory? So trajectory means the relationship between x coordinate and y coordinate. That is called trajectory. So basically we have to take the motions along x axis and y axis individually, and then we have to somehow relate them and show that that equation represents a parabola, right? Normally the equation of parabola that you may have studied in math or will study in math, normal equation of parabola is y is equal to y square is equal to 4ax. Okay, even though we will not get this equation, but it has to be, remember that either one of them. So how to show that? Either one of them, y or x, should be having a square term, and the other one will be in single order. So both sides cannot be having square term, both sides cannot have single also. So for example, y is equal to 4ax is a straight line, it's not a parabola. Okay, but yes, y is equal to 4ax square can also be a parabola. Obviously the axis will be changing, but yes, remember that either one of them has to have a power to the power 2. That is the only condition. In general, we write it like ay square plus by plus cx equals to some constant, say k. This is the general equation of a parabola. So as you can see, it can have square as well as single term. This will only have a single term. It can, x and y can interchange their places, but this is the general equation of parabola, and something like that we have to show for a projectile as well. So what is a projectile motion? Let's draw the diagram once more. So this is y-axis, this is x-axis. A projectile that you have projected move like this. Okay, so this is the velocity v, or you, if you are comfortable with u, also you can use u. I am using v here. This angle is theta. Then the x component of this is v cos theta, and the y component is v sin theta. Okay, after some unknown time, the projectile say reaches some point, and that point is given by x comma y. And if we can generalize this equation using x comma y, then basically our job is done. That is the only thing that we need to show, right? Now x comma, at x comma y we are trying to find the equation. Now how to do that? So if you see, this is x coordinate. So after some time t is given, known, actually it's not known, but it is assumed. After some time t, what is the displacement along x direction? So x component, first let us write the x component of velocity, that is v cos theta, and y component of velocity is v sin theta, right? Now after some time t, after some time t, okay, what is the x coordinate? X will be obviously velocity along x direction into t, because there is no acceleration in the x direction. In this direction acceleration is 0, whereas in the y coordinate there is a downward acceleration which is given by g, right? So x equals to vx t. Obviously t is unknown, so from here we will try to find the value of t, which is given by x upon vx. Okay, we will put the value of vx in due time, but for now let us keep it like this. For y coordinate, now let us find the y coordinate. So y coordinate is the main thing, hero of this game. Okay, so y is actually in the upward direction and there is an acceleration. So how to find y coordinate? It is basically you have to use the equation s equals to ut plus half at square. This formula we have to use for y. Instead of u, obviously we will be using vy into t plus half gt square. Obviously gravitational acceleration is acting downward, so this, instead of writing plus, this will be minus. Okay, minus half gt square. Okay, then reason being that gravitational acceleration is acting downward, whereas the y component of velocity is upward when we started. Okay, at any, after some, this time t is after it started from the beginning, so that's why you can use this equation, right? So this is the general equation. Now what we have to do, we have to substitute this value of t in this equation, that's it. Okay, and then put the value of vx vy, then you will get your equation. So y is equal to vy into t. Now let's put that value over here. So vy into x upon vx minus half g into x upon vx whole square, right? So we have simplified it, and now let's put the value of vy and vx. So it will be v sin theta into x divided by v cos theta. Okay, v cancels, and you get over here minus half g x upon v cos theta whole square, right? So you get sine upon cos, that is tan theta into x minus half g upon v square cos square theta into x square, right? So the equation that we are looking for is in the form, so we can write ax plus bx square, right? So y is equal to ax plus bx square. This is the form, general form of a parabola, and this equation represents parabolic path. So that means the trajectory of a projectile is a parabola. Now here, after writing this, you have to write what is a. A is tan theta and b is minus half g upon v square cos square theta. Obviously, we have taken b as a constant which is negative, that is fine, right? But this equation represents a parabola, so the trajectory of a projectile can be considered as a parabola, right? So now this derivation, you have to describe the diagram briefly, and then what is x component, what is y component, etc. You have to write it, and then this derivation, and 5 marks will be clear cut like a butter, right? You will secure 5 marks like a butter. This is one of the most important derivation. Now let's move on with the next question. The resultant of two forces. Now this is a numerical question. From this, generally there is no other 5 marker derivation. This is the most important derivation. Time period or range of a projectile, or g of height of a projectile. Height of the projectile I have done, but range of a projectile, not a 5 marker question. The resultant of two forces acting at an angle of 120 degrees is at right angle to the smaller force. If the greater force is 8 Newton, find the smaller force and the resultant. Okay. So resultant of two forces acting at an angle of 120 degree. So first let us draw the diagram and understand it. So we have two forces. Okay. The angle between them is 120 degree. Okay, this is say A vector, this is a B vector. The resultant, however, if you find the resultant, actually just a second. Resultant is actually in the perpendicular direction. So I think I need to change the diagram a little bit so that so this is the A vector, this is the B vector, angle between them is 120 degrees, and this is the resultant vector. Resultant vector is perpendicular to smaller force. So this A is smaller, A is smaller, and B is bigger or larger. Okay. So the greater force is 8 Newton. So B is given as 8 Newton in magnitude. Okay. Find the smaller force and the resultant. So first you have to find the smaller force and the value of the resultant. Both you have to find. How to do that? For that, this angle is given 90 degrees. Okay. And we know that for resultant tan theta is given by sin theta, the other one. So if you are using the angle with this vector, the other vector which is not involved in the angle measurement, so b sin theta divided by a plus b cos theta. Okay. So here sorry, one mistake I have made. This will be tan phi. Okay, tan phi is the angle. So in this question, phi is given as 90 degrees and theta is given as 120 degrees. So if you remember this single equation, then this problem can be solved without any difficulty. Now tan phi is 90 degrees. So 90 degree means tan phi, 90 is actually undefined. That means from if phi equals to 90 degrees, that means the denominator has to be 0. Okay. So tan 90 means tan 90 is actually infinity or undefined. It is basically 1 upon 0. Okay. Or some constant upon 0. So that means this quantity has to be 0. So A plus B cos theta has to be 0, right? We have done this kind of problems in our trigonometry classes. So if phi is 90 degrees, that means this must be equals to 0. Now what we are trying to find? We are trying to find the magnitude of A. Okay, magnitude of B is given as 8 Newton. So A equals to minus B cos theta. Don't worry about the negative value. Obviously theta is 120 degrees, so cos 120 will be negative itself. So let's put the value minus B. Instead of B, let me put 8 cos 120. Now what is cos 120? Cos 120 can be written as minus sin 30, right? Sin cos 90 plus theta. So 90 plus theta means minus sin theta, right? So minus sin 30, or it can be written as minus half. If you forget what is the value of cos 120, cos 150, in that case you have to either use complementary angle, or you can use 180 degree minus theta. That is also fine, right? Now let's see. So minus minus plus, so it will be cancelled and you get 4. So the value of A is 4. This is it. So value of A is 4. Now next part is to calculate the resultant. What is resultant? Resultant is given by square root of A square plus B square plus 2AB cos theta. Right, this is the formula for resultant. Use this value. Slightly tricky problem, but if you understand that how to solve it, what formulas to use, you can solve it. 8 square plus 4 square. Actually I should write opposite. A is 4, so 4 square plus 8 square plus 2 into 4 into 8 into minus half. Cos 120 is minus half. We have seen that once. So that value we are using straight away. So 4 square is 16. 16 plus 64 minus 32. Okay, you calculate this. This will come out to be 32. Obviously, this two cancels. So 4 8s are 32. So that means it will be 32 plus 16 square root of 48. Right? 32, 48. So it will be 4 root 3. So the answer is 4 root 3 Newton. Don't forget about the units. So every force or every quantity will have a unit, because the unit is given in this question. So every vector quantity will have the same unit, right? So the smaller force is 4 Newton. The larger force is 4 root 3 Newton, right? Let's move on. Next, a football player kicks a ball at an angle of 30 degree to the horizontal with an initial speed of 20 meter per second. Calculate the maximum height and B horizontal range reached by the ball. Easy question, straightforward question. Angle, so you are having a projectile motion, right? And the angle is given theta 30 degrees. Okay, initial speed is given, or let me write, generally for projectile I use V, so 20 meter per second. Okay, and they ask you to maximum height. So what is the formula for maximum height? It will be V square sine square theta upon 2g. Okay, V square sine square theta upon 2g. Okay, now sorry, just a small mistake. 2 will be in the multiplication. So 2 V square sine square theta upon g, that is the highest maximum height. So 2 into 20 square into sine 30 whole square divided by 10. Okay, so this is the maximum height. So that will be given by 2 into 400 into sine 30 means half. Half square means 1 by 4 divided by 10. 0 cancels. 4 tens are 10, so 20 meter. Maximum height is 20 meter. What about the range? Range formula is v square sine 2 theta sine 2 theta upon g. Okay, that is 20 square into sine 60 divided by 10. So that is 400 into root 3 upon 2 by there is no square by the way, so by 10, so this cancels and you get 20 root 3. 20 root 3 is the range and 20 meter is the maximum height. Let's move on with the next chapter, laws of motion. Obviously, we will start with MCQs. No force is required to keep an object moving in circular motion. An object moving in a straight line with a constant velocity, an object moving with a constant acceleration, both A and B. So, if you see that an object moving in a circular motion, okay, you do need a force which is called centripetal force, which is directed towards the center. So, this statement is incorrect and thus this statement is also incorrect. Now, object moving in a straight line with a constant velocity. So, when the object is moving with a constant velocity, you do not need any extra force to keep the motion. Obviously, according to the first law of motion, an object moving will continue to move with a constant velocity in the absence of external force. So, you do not need any extra force to keep an object which is already moving. Now, in our world, in our reality, we do need to apply force because of the frictional force which opposes the motion. But if you go in the space and if you throw something out in the space without having any gravitational effect, if you are basically no planets are there, suppose the distance between two galaxies where everything is empty, if you throw something, the object will continue to move with a constant velocity, right? But obviously that scenario is not possible on Earth. There are a lot of other forces acting on the object, right? So, an object moving straight line with a constant velocity is actually do not require any extra force. Obviously, object in rest we also do not require any force, but object moving with a constant velocity also do not require any force. So, this is very tricky MCQ. Make sure you read every MCQ before answering. Next question, what is the term for an object's tendency to resist changes in its state of motion? That is called inertia. Inertia is the property of an object which resists the change, right? For example, I am teaching you physics and you are trying to resist my teaching, saying that still though I do have exam tomorrow, but I still resist to study physics. So that is the inertia of physics, right? So if you overcome that inertia, once you start moving, once your wheel start moving, then you will overcome this inertia, right? So this is called inertia. Inertia means the resist, the urge to stop something. I don't want it, right? I don't want to study. I want to play free fire. Same thing is there as well. When object A exerts a force on object B, what force the object B exerts on object A? So this is a Newton's third law. So equal force but in opposite direction. So equal force, equal and opposite force. Every action has equal and opposite force. So if A applies a force on B, B applies the equal amount of force on A as well. Okay. Next question. Rockets work on the principle of energy, momentum, mass, all of this. Basically, rockets works on the principle of conservation of all of this. Okay, momentum is conserved, energy is conserved, mass is conserved. So, rocket works in the principle of conservation of everything. It's a little complicated motion. Actual rocket motion is a complicated motion and it works on the principle of all of these. It is not momentum, it is not only energy, it is conservation of mass as well, because some mass is going down, that means some momentum has to be converted. So this is a complicated scenario, and that's why sometimes for easy things we say this is not a rocket science, right? If you may have heard this, if you are watching some of the influencers, they always say this is not a rocket science. What does that mean? Because rocket science is complicated. Actual rocket science, designing a rocket, sending it to the space, is not so easy. Okay, that's why even nowadays we sometimes see some of the rocket would not reach to the space before even they reach the space, they break down. So that mishaps happen only because rocket science is not easy. Okay, let's move on. A cyclist bends while taking a turn in order to. So when you are driving a cycle and if you are taking a turn, your body bends a little. Why? Because you the part of your weight actually provides the required centripetal force. Okay, the provide necessary centripetal force. So when a cyclist actually driving, when he bends his body, weight is acting downward. So there will be a component along the direction of motion, and that actually provides the required centripetal force, right? Now next, a block of wood is placed on a surface. A force is applied parallel to the surface to move the block. The frictional force developed acts. So a block of wood is placed on a surface. A force is applied parallel to the surface to move the block. So we have a block. We have applied a force here so that the block is moving. Okay. So the frictional force developed acts along the direction of the applied force, opposite to the direction of applied force, normal to the surface upward, normal to the surface downward. So the frictional force always acts in the opposite to that of the applied force. The rule of friction is it always opposes the motion, it always works in the opposite direction. Okay, even if you consider the top portion, suppose you are applying a force like this, the force of friction will always act in the opposite direction. Okay, so it is always opposite to the direction of applied force. Friction always opposes. Next, fill in the blanks. Dash is a measure of inertia of a body. Mass is the measure of inertia of a body. So correct answer for this is mass. Now, as I mentioned, while you are doing the fill in the blanks, make sure that you check if the sentence is making any proper sense. Secondly, whenever you are finishing one, underline it so that you do not have to think it twice. When no external force is applied on a system, its total momentum is. When no external force is applied on a system, its total momentum is constant. So if no force is applied, then total momentum is constant. Next, a force acting for a short duration is called impulse. So the short force, which is very small duration, is called impulse. Impulse example. Can you tell me one example of impulse? So when a cricketer is hitting a ball, okay, the ball is, we say that the batsman have timed it perfectly. Timing means basically the impact is very short duration. He hit exactly on the time where the impact is very small, and that means the ball, the transfer of momentum is very high. Because of impulse, the momentum gets transferred from the bat towards the ball, and then the ball goes towards the boundary, right? So impulse is the short duration force where the contact is very, very short. Next, an equilibrium net force on a body is, at equilibrium the net force on a body is 0. So impulse is done, constant is done. So at equilibrium the force acting on a body is 0. Okay. Next is the SI unit of spring constant, Newton meter or Newton per meter. Both can be the option. Okay, so what is spring constant? Spring constant, if you multiply spring constant with the distance, you get the force. Spring constant means when there is a spring, if you compress it by some amount or if you stretch it some amount, okay, there is a restoring force that develops inside the spring. That is called spring constant. Okay, so the restoring force per unit length is called spring constant of that particular spring. So that means spring constant into distance is actually force. That means the unit of spring constant is Newton per meter. So the answer is Newton per meter, that is Newton meter to the power -1. Okay, if you remember the formula also, that is also helpful to answer this question. Now let's move on with the 2 marker first. Mention any 2 advantages of friction. Super important question. So it helps in movement. Friction allow us to walk, run and drive vehicles without slipping. Without it, we would just slide around. So if there was no friction, we would have used to have slider instead of wheels, okay, and we will not be able to walk on the surface of the earth, okay, and because there is a friction, we are actually able to walk on the surface of the earth, right? Sometimes it is called a necessary evil, okay. The same question when I was a student, it used to come like, why friction is called a necessary evil. So you have to give some uh, good points as well as some bad points. So advantage and disadvantages both you have to write and say that even though there are disadvantages, there are some advantages, and that's why it is called necessary evil, okay. Now anyway, enables gripping and holding objects. Friction between our hands and objects help to hold things securely like a pen or a cup. So I am holding this pen because the friction force between my fingers and the pen is allowing me. If there is no friction, if my fingers are oily or watery, then there will be less friction and my pen will slide from my finger, right? Or if I am not holding it properly, so that means the frictional force is less, so it will slide from my finger. Okay, it happens to me sometimes when I am writing, I am not applying enough force, so my pen slips from my finger. So whenever you are writing the exam paper, remember you are able to write the exam paper because of the friction, because when you are touching your ink on the paper, because of the friction, the ink is coming out of your pen, and that's why you are able to write the exam. So you are writing the exam because of the friction. So if there is no friction, there would have been no exam as well, right? Cool. Let's move on. What is an impulsive force? Give an example. An impulsive force is a force that acts on a body for a very short duration but is extremely large in magnitude. Despite acting for just a brief moment, it produces a significant change in the body's momentum. Hammering a nail, when hammer strikes the nail, a large force is applied in a brief instant, driving the nail into the wood or rail. Batting in cricket, when the batsman hits a ball, the bat exerts a huge force in a very short time frame, rapidly changing the ball speed and direction. Okay, so as I mentioned, so when you are hammering a nail, okay, you just touching it for a few seconds, and during that touching, if you touch it like this, it will not go. You have to hit it. That means the contact duration will be very small. When two cars collide, if the collision time is very small, then also basically there will be huge damage as well. That's why they have some zone which is called crumple zone, where there is a vacant space in front of every car and in the back as well, so that when they collide, that collision time can be increased. Okay, instead of reducing the collision time, the collision time is increased, so that the transfer of momentum happens slowly, and even though car gets damaged, but your life, the passenger's life, remains safe. Okay, so that is also an application of impulsive force. Now let's move on. What is banking of roads? Why banking is necessary for curved road? Banking of road is the process of raising the outer edge of a curved road above the inner edge, creating an incline at a specific angle. So when you are traveling on a road, you may have seen that whenever there is a curve means the road is, suppose there is a road which is turning like this. So the road is not flat. Okay, the outer edge of the road is little high than the lower edge. Okay, so it is possible in any highways also. So when you are traveling on a highway, okay, you will see that the highway road also like this. Okay, so they build the road such that the outer side, so when you are taking the turn, okay, the direction you are taking the turn, this is the inner side, and the opposite side is the outer side, and they raise the outer side so that when you are taking the turn, you can take the turn carefully, and you get the required centripetal force. Okay, this inclined surface is designed so that when a vehicle negotiates a curve, the normal reaction from the road surface has a component that acts towards the center of the circle, providing the necessary centripetal force for the circular motion. For example, let me give you an example. So suppose this is the road. Obviously, I cannot draw a three-dimensional road. I will draw a two-dimensional incline. Okay, this is the road. This is the vehicle which is taking the turn. Okay, now there is a normal force. Okay, obviously there is a weight of the body acting downward. Some component of the body is in this direction. So there will be a normal component, and this normal component will have a component in this direction and one will be in this direction. So this direction normal force actually balancing the weight, and this direction the normal reaction actually balance giving the required centripetal force, because when you are taking a turn you do need a centripetal force for any circular motion, be it half circle, be it full circle, be it a very small circle. As long as you are taking a turn, that means it's a part circular motion. So in case of circular motion, there will always be need for a centripetal force, and centripetal force, some part is provided by the friction, the remaining part is provided by the normal component. Actually, in real life situation, it is actually friction as well as the banking both combined provide the required centripetal force. So if you see that, if you have seen MotoGP races where the bike races, right, you have seen in sports channels. So when they come near a turn, they bend their body extremely low. Okay, why so? Because they want a high centripetal force. Okay, if they are taking the turn normally, then they will not be able to take the turn in a high speed. Okay, they have to slow down, then only they will be able to take this turn. Otherwise, they will skid and hit the barricade, and they will probably have a fatal injury. So that's why when they are taking the turn in the corners, they slow down a little, but also they bend their bodies extremely low, even touch their knee to the ground. Okay, they have a knee pad, knee cap, obviously a safety guard device there. But otherwise, why they do that? Because when they are taking a turn in a very high speed, okay, if they are bending their body to the ground, and at that point they are getting the required centripetal force. Okay, that's why they can take the turn in a very high speed and they don't lose out on the race, right? Let's move on. State and explain Newton's second law of motion. Define SI units of force. Super important question. Many students only answer the state and explain. They do not mention the SI unit of force. The rate of change of momentum of a body is directly proportional to the applied force and occurs in the direction of the force. So mathematically, F is equal to ma, where F is force applied, m is the mass of the object. Also units are mentioned over here. A is the acceleration of the acceleration produced. SI unit of the force is in Newton. Definition: 1 Newton is the force required to accelerate 1 kg mass by 1 meter per second square. So 1 Newton force is the required to accelerate 1 kg mass with an acceleration 1 meter per second square. Now next, mention any three methods of reducing friction. So as I mentioned, friction is good, but sometimes we need to reduce the friction, especially for example wheels or some vehicles where we are driving it. We want to reduce the friction between the internal parts. Externally friction is there, that is helping the vehicle to move, but when the wheel is rotating along its axle, we want to reduce the frictional force between the axle and the wheel. Okay, we want the frictional force on the ground only. That ground frictional force is actually helping us to move, but the internal frictional force is actually reducing its efficiency. So we want to reduce that. How to do that? By lubrication. The easiest way to lubrication, applying lubricating lubricants like oil, grease, etc. So if you see, if you are using a bicycle, sometimes you spray some oil into your chain so that the frictional force reduces, right? Polishing the surface, making the surface smoother by polishing, that also reduces the friction. Secondly, using ball bearings, replacing sliding friction with rolling friction by using ball bearings. So if you your wheel also always have a ball bearing structure, so that the linear friction is not there, only rotational friction. Rotational friction is always less than that of the linear friction or sliding friction. Okay, so rolling friction or rotational friction is always less than that of the linear or sliding friction, right? That's why we use ball bearing. So this is also very common question. Next, derive an expression for maximum speed of a circular motion of a car on a level road. Okay, so maximum speed, so we have a car, let's say a car is moving on a circular path. Okay, so it is moving with the say some velocity v. We have to find this maximum velocity with which it can move. So obviously it requires a centripetal force to move. Okay, and what is the formula for centripetal force? Centripetal force is given by m v square upon r. Okay, this is the centripetal force that is required. Now, if you consider the 2D diagram, in the free body diagram, so there is a centripetal force in this direction. Okay, there is a weight acting downward and there is a frictional force. Okay, in case of centripetal motion, the frictional force in the same direction as centripetal force. Okay, so centripetal force is actually provided by the friction. Now, what is friction here? The weight is W, that means the normal force will also be W. Okay, level road is not banked. Banked one is not going to come in the exam, but level road might come. So you have to remember this. So force of friction is given by the coefficient of friction into normal force. Now, what is normal force? Normal force is mu m g, right? So now, when the car is moving on a normal level road, the centripetal force must be equals to the force of friction. So, force of friction is actually providing the required centripetal force. There is no other component. Weight cannot help over here. Normal reaction is also perpendicular to the direction of motion. So, in that case, we have to write mv square upon r equals to mu mg. Mass cancels. So, v equals to mu g, v square equals to mu g r, or v equals to square root of mu g r. Okay, so this is the maximum speed with which the car can move on a level road. If the road is level, only this is the speed. If you are giving it a banking, then speed can be little higher than this as well. Okay, so this is the minimum speed. Obviously, it does not depend on the mass of the vehicle. So even if you are driving a heavy vehicle or a light vehicle, it does not matter. Speed has to be same. Okay, and it depends on the coefficient of friction, gravitational acceleration, and the radius of the rotation curve. Okay, so there is a radius. Obviously, it's a curve, means there has to be some radius of the road of the curvature. So radius of curvature is also important, right? If the curve is very long, a high radius of curvature, then you can move with a high speed. But if the curvature is very small, the circle is small, then you have to move really slowly. Okay. Next, state the law of conservation of momentum. Prove laws of conservation of linear momentum using Newton's laws of motion. Another super important question. So, law of conservation of momentum. The total linear momentum of an isolated system remains constant if no external force acts on it. So, total linear momentum of an isolated system, do not ignore it. Isolated system means system is not in contact with each other. Okay, so total linear momentum of an isolated system remains constant if no external force is acting. Now we will consider two bodies, body A and body B. We have to prove the law using Newton's law of motion. So there are two laws of motion, F is equal to ma, and third law of motion, force acting on each other will be opposite. So these two laws we have to use. Now see, suppose this object A was moving with some velocity, say ua, and this one was moving with some velocity ub. Okay, this is the two objects which are there moving with each other. Mass of A is ma, mass of B is mb. Now they collide with each other, and after collision, now they are moving in the opposite direction. VA and VB. Okay, so this is the basic concept that you have to remember. So two objects coming towards each other, they are applying force on each other, and then they are getting separated. Now when they are colliding with each other, Object A is applying a force Fa on object B, and object B is applying a force Fb on object A. Okay, so they are applying a force on each other, right? Now, suppose the contact duration is very small, delta t. Now, what is the initial momentum of this system? Initial momentum is what is momentum? Momentum is mass into velocity. Now, when multiple objects are there, you have to add them. MAUA plus MB UB. What is final momentum? Final momentum is MAVA plus MB VB. Our job is to show that they are equal. Okay, so if you get to show that they are equal, then only your derivation will be completed. Now, how to do that? So, first we will be using that when they are colliding for a very brief amount of time, okay, the object A is applying force on B and object B is applying force on A. That means from Newton's third law, FA must be equals to minus FB. They must be equal and opposite, right? So, again from second law, this is third law. From second law, what is FA? FA is MA acceleration A equals to minus MB acceleration of B, right? F is equal to MA, father equals to ma. Remember, father equals to ma. So, that means from second law, we just need to put the acceleration formula and rest is done. Now, you just need to put what is acceleration A and what is acceleration B and simplify it, you will get the answer. So, what is MA? Oh, sorry, what is A? So, here original speed was in this direction, final speed is in the opposite direction. That means it will be VA minus UA upon delta t times. So, this is the contact duration, small contact duration. So, during the small contact duration, acceleration will be change in velocity divided by time. Similarly, for object B, it will be final velocity minus initial velocity divided by same time delta t. That's it. So, if you have established this much, the problem is solved. Okay, only thing you need to remember what is acceleration over here. If you remember what is acceleration, then the problem is very, very simple. Delta t is cancelled. Obviously, delta t is not 0. Now, simplify. MA VA minus MA UA equals to minus MB VB plus MB UB. Why plus? Because minus minus plus. Okay, now take this, all V should be on the same side. So, MA VA plus MB VB equals to MA UA plus MB VB. So, that is MB UB. So, final momentum equals to initial momentum, right? So, final momentum is equal to initial momentum, thus the conservation of momentum is proved. Very easy derivation, 5 marks is guaranteed, but the diagram you have to draw, you have to show what is the initial, what is final momentum, and then from third law, what is the relationship between the forces. From second law, what is the relation, how to revert, go from force to acceleration and from acceleration to change of velocity, right? Rate of change of velocity is acceleration. So, change in velocity divided by time. Remember, always final minus initial, final minus initial for both sides, final minus initial. and just simplify it. If you practice it at least once, you should be able to solve it without any difficulty. State Newton's second law of motion, hence derive the relation F is equal to ma. Now, second law of motion I have already, the statement is already there. The force acting on a body is directly proportional to the rate of change of momentum. That is second law of motion. From there, you have to prove F is equal to ma. Obviously, differentiation is not done. I will do it in normal way. So, suppose we have an object of mass m, okay, and it was moving with a, say, a speed of say, or initially it was at rest. Assume initially at rest, okay, you apply some force on it, okay, and it started moving. So initially, suppose no initial velocity we need to assume. Initially it was moving with the velocity u. Now you applied some force and it started moving with the final velocity v. Okay, suppose you applied the force for a time duration t. Okay, these things you have to assume and you have to write it down. Okay, now according to Newton's law of motion, the applied force is proportional to the rate of change of momentum. What is rate of change of momentum? Rate of change of momentum means initial momentum, final momentum minus initial momentum. Okay, final momentum is mv. So after application of force, the final velocity is v. So final momentum is m into v, and initial momentum m into u, right? So just put these values, and rate means you have to divide it by the time t. This is Newton's law. Force acting on an object is directly proportional to rate of change of momentum. That's it. Newton's law does not say F is equal to ma directly. So you have to show that. Or F proportional to, if you take m common, you will get v minus u upon t. Now what is v minus u upon t? V minus u upon t is the rate of change of velocity. So rate of change of velocity is defined as acceleration. So that means F is proportional to m a. Now it is not equals yet. Remember, it is not equal yet. So from now we have to put F is equal to k m a. K is constant of proportionality. Now remember, I have seen in some book it is mentioned let k equals to 1. So F is equal to ma. So let means I am assuming. I can let k is equal to 100. Then F is equal to 100 ma. Is it so simple? You cannot let k is equal to 1. You have to show k is equal to 1. That is important. Do not write let k equals to 1. After doing this derivation, I hope most of you have done this derivation, and after doing that you write let k equals to 1. So F is equal to ma. If I am checking this, I will deduct straight away 3 marks. I will give you only 2 marks for a 5-mark derivation. Okay, so remember that this is not correct. So there is a reason, that's why this is written. Newton has done it for some reason. So do respect that process. So here we are defining the unit of force. If we do not define unit of force over here, then k cannot be 1. So the unit of force or unit force is defined such that if m equals to 1, a equals to 1, then F will be equals to 1. This is how the unit of force is defined. If m is equal to 1, a is equal to 1, then F is equal to 1. Now if you put all these values, you get 1 equals to k into 1 into 1. That is, the value of k is coming out to be 1. It is not let. It is equals to 1 from the definition of unit of force. Okay. So we can write, therefore F is equal to NA. So this line actually weighs more than whatever you have done over here. This one line is super duper important. This is the definition of unit of force. So do write that if you are writing this derivation, if this derivation comes in your exam. Okay, they will not give you 5 marks for free, right? A driver of a car, now let's solve some numerical questions. A driver of a car moving at 25 meter per second sees a child on the road 70 meter ahead and stops the car 20 meters earlier to the child. If the mass of the car with the driver is 1000 kilograms, calculate the force exerted by the brakes on the car and the time taken to stop the car. So a car was coming. He sees some child over here. Okay, and it applies brake and it stops. Okay, 20 meters earlier. So 20 meters earlier, the car stops. Originally, it was 70 meter. Right? Originally, the car sees a child on a road 70 meter ahead. Right? So he applies brake and it stops 20 meter earlier. That means the car has traveled how much distance? 50 meter distance. Initial speed is 25 meter per second. So U is 25 meter per second. So you have to first find what is the acceleration or retardation. Basically, the force exerted by the brakes F is equal to ma. Before calculating that, first step is to calculate the retardation. Now, obviously, the final velocity when the car is stopping, final velocity is 0. To calculate retardation, obviously, we will be using v square equals to u square minus 2as. Negative sign represents the acceleration is negative. So final velocity is 0, initial velocity is 25, okay, and minus 2 into a into s is 50. Right, the displacement of the car is 50 before it is coming to rest. So using this equation, we need to calculate the value of a. So 100 a equals to 625. 25 into 25 is 625. So a equals to 6.25 meter per second square. So we have calculated the acceleration. Next step is to calculate the force. So the force applied by the brake is given by father equals to ma, that is mass of the car is 1000 and acceleration is 6.25, that is 6250 Newton. This much force is applied by the car by the brakes. Okay. Next, the time taken to stop the car. You have to also find the time taken to stop the car. For that, you have to use another equation of motion. So this is part A. Okay, part B is v is equal to u minus 80. Okay, v is 0, u was 25. A we have calculated 6.25 into t. So t equals to 25 by 6.25. So it will be 10 by 2.5. It will be 4 seconds. It will be 4 seconds. Okay, you can use your calculator. How I calculated does not matter. Yes, I calculated in my brain quickly. I do not remember even after a long time. I am taking a PU1 class. Okay, I did in last year final board exam, and since then I have not taken any PU1 classes. But yes, so 25 by 6.25 is 4. You can check it using your calculator. Now next is a body of mass 2 kg is acted upon by two perpendicular forces 4 Newton and 7 Newton. Calculate the magnitude and direction of the acceleration of the body. Interesting question. So two forces are perpendicular to each other. Okay, 4 Newton and 3 Newton. Suppose this is 4 Newton, this is 3 Newton. Okay, first we have to find the resultant of these two forces. So two perpendicular forces means angle between them is 90 degrees. Theta equals to 90 degrees. So what is the resultant? We will use vector addition formula. 4 square plus 3 square plus 2, 4 into 3 into cos 90. So cos 90 is 0. So this term actually will be 0. So we get square root of 4 square plus 3 square is equal to 5. Okay, 4 square plus 3 square is a perfect number. So 26 plus 9, 25, that is square root of that will be 5. So those who have practiced Pythagoras theorem long enough, they can answer it easily, right? So resultant is calculated. Now next part is calculate the magnitude of acceleration. So what is acceleration? Obviously we know that force, resultant force is equals to ma. Okay, here this is the force, this is the force, right? So force equals to ma. Don't afraid of, always we write F is equal to ma, but here the force is written as R, that's why we are writing ma. So resultant is 5 equals to object mass is 2 kg into A. A equals to 5 upon 2, that is 2.5 meter per second square. Unit is super important. Okay, here also the resultant force is 5 Newton. Okay, next part is the direction. So if the acceleration is acting say at a direction angle phi, if it is acting at an angle phi with the 3 Newton force, then tan phi, what I mentioned, the other vector, this vector, okay, 4, that is 4 sin 90 divided by 3 plus 4 cos 90, right? 4 sin 90 divided by 3 plus 4 cos 90. So that the division becomes this quantity. If you ignore everything, it will be tan theta. That is it. Right? This phi angle you have to calculate. So it will be now sin 90 is 1, cos 90 is 0. So it will be 4 upon 3. So tan phi equals to 4 upon 3, which is actually phi equals to, I think, 53 degrees. Okay, you don't need to write it if you don't know it, but you can still write tan phi is equal to 4 upon 3, that is the direction with the 3 Newton force. Okay, with the 3 Newton force. Direction is 53 degree with the 3 Newton force. If you don't know, you have to write in terms of tan inverse. Okay, tan inverse 4 upon 3, right? You can, from here you can write phi is equal to tan inverse 4 by 3. Okay, so this is the angle that is the acceleration makes with the 3 Newton force. Okay, the angle will be different with 4 Newton, so you have to mention with which you are measuring the angle. Okay, next is work energy power. Last chapter, we will finish it quickly. The work performed on an object does not depend upon the displacement, the force applied, the angle at which the force is applied on that displacement, initial velocity of the object. So work performed on an object is given by W equals to Fx cos theta. Okay, so if you are applying a force on an object at an angle theta, okay, and the object is getting displaced by a distance x, then work done is given by Fx cos theta. So force depends, the work done depends on the displacement, the force as well as the angle, but there is no relationship with velocity. So obviously the work done does not depend on velocity of the object. Next, a particle made to go around a circle with a constant speed with the help of a rope. The work done by the rope is, so a particle is rotating in a circular motion. So when it is circular motion, if it is completing a single complete rotation, that means at this point the displacement is 0. The displacement is 0 means the work done is 0. Also you can say that at any point of time the centripetal force is in this direction, velocity is in this direction. So the displacement is in the perpendicular direction. So force and the displacement are in the perpendicular direction. So in that case also you might say that the work done is 0. So no matter what explanation you choose, work done in a circular motion will always be 0. Move on. If a light body and a heavy body have same kinetic energy, then which one has greater linear momentum? So two objects have same kinetic energy, but which one will have the greater kinetic momentum? So for that you have to remember a very small trick, that momentum is given by square root of 2 into mass into kinetic energy. P is equal to square root of 2 mk or ek. Okay, so this is the formula that you have to remember. Now it mentioned that two objects have same kinetic energy. Okay, two objects have same kinetic energy. So kinetic energy same means ek is same. Okay, so who will have the greater momentum? So you can see that momentum is directly proportional to square root of mass if kinetic energy is constant. Okay, if momentum is constant, then there will be a something else who have the kinetic energy, but for momentum is greater for greater mass. So if two objects have same kinetic energy, the greater linear momentum will be for the object which has a greater mass. Okay, so heavier body will have higher momentum. Linear momentum, in terms of linear momentum, the heavier object will have a higher momentum. If you are talking about kinetic energy, suppose the same question is asked. Now they said that momentum is same, momentum is constant, who has the highest kinetic energy? So in that case, using the equation, we can write P square is equal to 2m into Ek, or kinetic energy is equal to P square upon 2m. So if this is constant, that means kinetic energy is proportional to 1 by m. So lighter object will have a greater kinetic energy. So this is very tricky. Remember, if momentum is constant, kinetic energy will be more for a lighter object. Whereas if kinetic energy is constant, momentum will be greater for the heavier object. Okay, so this is very interesting question. Both can be asked, so be careful. This is actually a slightly lower level question in compared to PUC. Okay, but in lower level classes, when you are studying, many portions were deleted because of the COVID. Now your PUC is feeling hard because of that. Okay, the potential energy of a system increases if work is done upon the system by a non-conservative force, by the system against a non-conservative force, by the system against a non-conservative force, upon the system by a conservative force. The potential energy of a system increases if work is done on the system, okay, by a conservative force. So upon the system by a conservative force increases its potential energy. For example, I am giving you one very simple example. You have a box lying on the ground. Okay, so this is the box is the system, and the conservative force is gravitational force. Okay, now you are taking that box from ground floor and you walk across and you move towards the first floor balcony. Okay, your house or your home is in the first floor. You walk across first floor and move it into the first floor balcony. So in this case, by lifting that box from ground floor to first floor, you are doing work on this system. So work is done upon the system against a conservative force. If it is a non-conservative force, for example, friction, no matter how much work you do against a friction, you are not going to increase the potential energy. The potential energy increases only in case of conservative force. Now there are two major conservative force that you are aware of: electrostatic force as well as gravitational force. Later on, magnetic force is also a conservative force. So there are main three forces that we know about: conservative forces, gravitation, electrostatic, and magnetism. So these are the conservative force. Non-conservative force example is friction. Okay, drag force. Drag force is also non-conservative force. Let's move on. Which type of collision in which both linear momentum and kinetic energy of the system remains constant before and after the collision? Remember, no matter what is the type of collision, linear momentum will always be conserved. Only kinetic energy will be conserved for elastic collision. For elastic collision, kinetic energy will be conserved, and for all types of collision, elastic, inelastic, semi-elastic, semi-inelastic, all types of collisions, momentum will be constant, right? Momentum is always constant. So momentum is common. Momentum and kinetic energy is for elastic. Only momentum for all type of motion, all type of collision. Okay. So momentum and kinetic energy for elastic collision only. Only momentum is for everything, only kinetic energy is not possible. Momentum will always be conserved. Okay. So, here the answer is elastic collision. Next is state and explain work energy theorem for a constant force. The work done by a constant force on an object is equal to the change in its kinetic energy. You should also prepare the non-conservative force, but for a variable force, but for unit test, first unit test, I am not expecting to they give you the variable force work energy theorem. In before your midterm exams, I will definitely revise that question as well. But I am not recommending that to study, because this is the last chapter and entire chapter is also not completed. So, they may not give you complex questions from this chapter. Mention any two properties of elastic collisions. In elastic collision, total momentum of the system before and after the collision remains constant. The kinetic energy before and after the collision remains the same. So, this is the two elastic collision, again the same properties. Illustrate the conservation of mechanical energy in case of a body dropped from a height h. From this chapter, we are not expecting any numerical question, but this one single derivation is important up to whatever you have studied. So, here we have an object which is kept, say, at a height h from the ground, which is kept at a height, say, capital H from the ground. Okay. Now, at this point A, everything is potential energy. So, if you keep an object at a height, entire energy of the object is potential energy. Now, if you allow the object to drop somewhere when it is starting to fall, somewhere in between, suppose now next position is C, B, at this position it is potential energy plus kinetic energy, and exactly just before reaching the ground, okay, the entire energy is kinetic energy. Okay, we basically have to calculate these three energies and show that the energy is constant. If the energy is constant, then we will say that the total energy of a body is constant. Okay, conservation of mechanical energy. So, at this point A, entire energy is potential energy. So, what is that potential energy? The potential energy is given by mgh. This is the potential energy or total energy as well. We are mainly interested in total energy. Potential energy, kinetic energy we will calculate individually, but yes. So, this is the total energy of the system. Now, when it is falling from A to B, suppose it has travelled a distance of x and it is falling under the gravity. So, gravitational acceleration is z. Initial velocity is obviously 0. At this point, suppose the velocity is v, vb. Okay, at this point, suppose the velocity is vb. So, when it is fallen by a distance x, okay, starting from 0 velocity, gaining a velocity vb with an acceleration g, okay, what is this value of vb? So, we will be using a simple equation, that is final velocity square equals to initial velocity square plus 2g into x. Okay, this is the displacement x, right? Now, why we are using plus over here? For projectile motion we use negative. So, if that question comes to into your mind, remember projectile motion is object is moving from ground to up. Here the object is coming from up to down. That is why velocity and acceleration are in the same direction. That is why this sign is positive. Now, obviously, u being 0, we can write vb square is equal to 2g x. We will leave it. We will leave it at equation, or you can also find the kinetic energy. Let us find the kinetic energy. Kinetic energy is half m v square, that is half m vv square, which is half into m into 2gx. Okay, v square itself is 2gx. So, no need to square or do anything. So, it will be mg x. So, this is the kinetic energy. This is the kinetic energy at B. Now, what is the potential energy at B? So, initially the object was at a height h. Now, it has come down by a distance of x. So, now the height is h minus x, right? This is the height. So, potential energy is given by mg h minus x, right? Mg h minus x. Now, what is the total energy? total energy is kinetic energy plus potential energy, which is mgx plus mg h minus x. Now, if you take mg common, you can get so total energy at point B. This is total energy at point A. Okay, this is point B. Total energy at point B. That will be mg. You take common, you get x plus h minus x. So obviously x cancels, and you get mgh. So at B also the energy is mgh. One more point left, point C, where entire energy is converted into kinetic energy. Now remember, when you are considering point C, you have to start from the top and consider that the object has fallen a height of h. Okay, do not start from C now. Okay, you have to start from the top again. Okay, so now for point C, entire energy is kinetic energy, potential energy is 0. For kinetic energy, obviously half mv square you have to calculate. Now for that, again we will be using that at point C, suppose the entire velocity of the object is vc. So entire velocity is vc. So in that case, what we will be using, we will simply use vc square equals to u square plus 2gh. Okay, same formula we are using, but we are starting from the top again, because at the top u is 0. Okay, and the height is also known, which is h. Okay, so it will be vc square is equal to 0 plus 2gh, that is 2gh. So 2gh, that is the vc square. Now kinetic energy, we have to calculate kinetic energy. Kinetic energy is given by half m vc square, which is given by half m into 2gh. So 2 cancels, that is mgh. Now total energy at point C, obviously potential energy is 0, so everything is kinetic energy, that is mgh. Okay, there is a last statement that you have to write. So statement is that energy at A equals to energy at B equals to energy at C. So energy is conserved, so that total mechanical energy of the falling object is constant throughout its motion. So 3 points are necessary: starting point, somewhere in between point, and end point. Okay, so if you follow this process, this is a easy derivation, but this derivation is asked many times. Okay, and mention that initially velocity is 0, at this point velocity is vb, at point C velocity is vc. So everything has to be described, the diagram has to be drawn properly, and with this you will get the full marks, right? So this is the last question of this discussion. We had a very long discussion, right? To clarify you that very important points is that all the questions are super duper important, so do practice it. If you want the PDF, you join our WhatsApp channel. The link of the WhatsApp channel is given in the description section of this video. Also, if you have any doubts, any other questions, do mention that in the comment section. And very important point, if you have not yet subscribed, don't forget to subscribe to our channel immediately, right? I'll be back with more helpful tips and tricks for your PU1 preparation as well. So stay tuned. Till then, bye, and all the best for your FA-1.